All right, so welcome to this class. So in this class, we are looking at row echelon form, okay, versus reduced row echelon form. Okay, so we are going to discuss these two concepts, and then we are going to solve questions about these same concepts here. Okay, so if you have any questions, please feel free to ask whenever I explain anything that you do not understand. All right, so this is linear algebra. So we start our discussion with the conditions required for a matrix to be known as the row echelon what form. Okay, so if you have a matrix, okay, let's say this matrix is matrix A. Okay, so for this matrix A to be in row echelon form, okay, three conditions must be met. Okay, so here I was saying a matrix is considered to be in row echelon form. Okay, short form is just REF if it meets the following conditions. Okay, number one, the zero rows should be at the bottom. Okay, so all rows consisting entirely of zeros, okay, they are grouped at the bottom of the matrix. Okay, so all the zero rows should be at the bottom of the matrix. Okay, or in other ways, we are saying all the zero rows, okay, should come after the non-zero rows. Okay. And then the second condition is the leading entry progression. Okay, so what do we mean by the leading entry progression? We mean that the first non-zero entry, okay, in a row, okay, so the first non-zero entry in a row, which is called the leading entry or the pivot, okay, must be to the right of the leading entry in the row above it. Okay, so this is the second condition. And then the third row is that all the entries below the leading entry must be zero. Okay, all the entries below the leading entry should be what? Should be zero. So those are the three conditions that we need in order to say that a matrix is in what? Row echelon form. So for example here, okay, I have this matrix that you can see here. Okay, so on this matrix here, okay, on this matrix here, remember our first condition, we said all the zero rows, okay, or all the rows that consist of entire zeros should be at the bottom. So we can see that this row here at the bottom, okay, has all zeros like that. Okay, so that is the first condition. And then the second condition we said, okay, the second condition we said the leading entry, okay, in each row should be to the right, okay, of the leading entry in the what? The previous row. So this is the first row here. Okay, this is the first row. So the first non-zero entry there is called the pivot, okay, or the leading coefficient. So in this first row here, the leading coefficient is this 2. And then in this second row here, okay, the leading coefficient, which is the pivot, is the first non-zero entry, which is what? 7. So in this row here, okay, in this row here, the first non-zero digit is 7. So we're going to say that is our pivot. And then in this third row here, the first non-zero digit is this 5, okay, and then this one has just zeros. So the rule says that, okay, the leading entry, okay, in a row should be to the right of the leading entry in the previous what row or the row above it. So this one here you can see is 2. The next leading entry you can see it's 7. So this 7 is to the right of this 2 here. Okay, you can see this is 2, and then when we're going to the right here, we find the leading entry of the other row. Okay, and then we also check the row below this row here. We have this leading entry here. Even this leading entry is to the right of this one. So that's how it should be. Okay, if I have a leading row, a leading pivot there or a leading entry there, okay, the other leading entry should be to the right of this one. So it can be there. Okay, another leading entry should be to the right of this one. It can be there. Another one should be like that, just like that. Okay, that's how we should move. And then we said the third condition was that, okay, we said the third condition was that all the entries, okay, below, okay, all the entries below the leading entry should be zeros. Okay, so in this first row here, the leading entry is this one. And we can see that below it, we only have what? Zeros. Okay, and then even here, the leading entry is this. Below it, we only have what? Zeros. Even here, the leading entry is this. Below it, we only have what? Zeros. Okay, so this matrix that I have here satisfies all those three conditions that we said should be met for a matrix to be in row echelon what form. So we're going to say indeed this matrix, we can call it matrix B, is in what? Row echelon what form. Why? Because it's satisfying all these three conditions that we have here. Okay. All right, and then from there, we can talk about the reduced row echelon what form. Okay, so the reduced row echelon form is just an extension of the row echelon form. Okay, so for a matrix to be in reduced row echelon form, the first thing that should happen is that that matrix should be what? In row echelon form. And then for it to be in row echelon form, we said three conditions. One, all the zero rows should be at the bottom. Two, the leading coefficient, okay, should be to the right, okay, of the leading coefficient in the row above it. And then three, all the entries below the leading coefficient, okay, should be what? Zero. So that's what we mean by row echelon form. And then we are going to add two more conditions to put it in what? Reduced row echelon form. Okay, so for the reduced row echelon form, we also have these two extra conditions. Okay, the first one, okay, it deals with or it's considering the leading coefficient. Okay, so in reduced row echelon form, the leading coefficient or the pivot should always be what? 1. Okay, when you're talking about the reduced row echelon form, the leading coefficient or the pivot should always be what? 1. Okay, and then the other condition is that the leading coefficient, which is this same one, okay, in each row, the leading coefficient, okay, should be the only non-zero digit in that column, okay, or we can say all entries in the column with the leading entry, okay, in this case, our leading entry is just what? 1. All the other entries in that column where the leading entry is should be what? 0. So if we have a matrix that satisfies all these conditions here, we're going to say that matrix is what? In reduced row echelon what form. So it's very simple as long as you understand the rules. Okay, so let's take a look at this matrix here. Okay, let's take a look at this matrix. Okay, so first of all, let's identify the pivots. So the pivots, they are the first non-zero digit, okay, in that row. So we have how many rows here? We have this row, we have this row, we have this row, and then we have that row. Okay, so the first non-zero entry is this one. In this one, the first non-zero entry is this one. And then in this third row, the first non-zero entry is this one. And then this one has zeros all over it. Okay, so it should be at the bottom. Okay, so first of all, let's check if it's in row echelon form. Okay, so row echelon form, we said the zero row should be at the bottom. We can check that. Okay, and then we said the leading coefficient. Okay, the leading coefficient in um, the the leading coefficient, okay, in the row below the first row, okay, should be to the right of the leading coefficient in the row above it. So we see that here we have this leading coefficient, okay, and then to the right of it, we have another leading coefficient. To the right of this, we have another what? Leading coefficient. So we can check that, okay? And then the third one, we said all the entries, okay, below the leading coefficient should be what? Zeros. So this is the leading coefficient here, and I can see I have zeros all over below it, okay? This is the leading coefficient here. I also have zeros below it. Then this is the leading coefficient here. I also have what? Zeros below it. So we can check that. So we have shown that this matrix is in row echelon form. Okay, but is it in reduced echelon form? In reduced row echelon form. Okay, so we have to check the properties. Okay, those additional properties that we said. Okay, we said for it to be in reduced row echelon form. First of all, it should be in row echelon form. We've proved that. And then the other condition was saying all the leading coefficients should be what? 1. So we see that this leading coefficient is 1, this leading coefficient is 1, this leading coefficient is 1. So we can check that one. Okay. And then the other one we said all other entries, okay, in the column where you have your leading coefficient, okay, all other entries in the column where you have the leading coefficient should be what? Should be 0. So this is my leading coefficient. All the other entries here, you can see they are 0. This is my leading coefficient. All the other entries, 0, 0. This is my leading coefficient. All the other entries, they are what? 0. And then even there, they are what? 0. So it means this matrix here satisfies all the conditions, okay, of being in row echelon form as well as the reduced row echelon form. Right, so any questions there? Any questions there? Right, so we can do a comparison here. So I put reduced row echelon form here and then reduced row echelon form there. Okay, so let's recap. Okay, so we said the row echelon form, the 0 row should be below there. Okay, and then the pivots, okay, should be to the right of the pivot in the row above it. Okay, so these are the pivots here, the ones that I've put in yellow. We can see that the other pivots are to the right like that. Okay, and then the 0 row is down there. So this one here is in reduced row echelon form. So notice that in, row echelon form, not reduced, this one in yellow. Okay, so notice that in row echelon form, okay, the pivot, okay, the pivot is not 1. Okay, it can be any other number. Okay, the pivot is not 1, it can be any other number. And it's not the only non-zero digit in this column where it is. Okay, so that's the row echelon form. And then when we come to the reduced row echelon form, we said the pivot should always be ones like that. Okay, those are pivots. And then the 0 row, of course, should be at the bottom. Okay, and then in this column here where we have our pivots, they should be the only ones that are non-zero. Okay, if we compare it to the row echelon form, if this is my pivot, I also have 1 and 3 here which are non-zero. But for the reduced row echelon form, if I have my pivot here, it means all other entries, okay, in that column should be 0. So that's the difference there. Okay, I hope you can see it. That's the difference there between the row echelon form and the what? The reduced row echelon form. All right, so we can proceed if there are no questions. So I have this series of questions here to just test our understanding, okay, on the row echelon form. So I'm saying, which of the following matrices are in row echelon form? So let's look at the first one here. So I'm going to be asking you, okay? So anyone who can try, okay? Is this first matrix on A, is it in row echelon form or is it not? Anyone who can try? Is it in row echelon form? The first one there. Okay, so the first matrix here on A is not in row echelon form. Okay, so what are the reasons? Because the first row here has no pivot. Okay, it has no pivot there. There's 0 there, so it has no pivot there. Okay, and then we can also say that if you look at this second row here and this third row, okay, the pivot in the third row is not to the right of the pivot in the row above it, okay, because this one here would mean that this pivot here in the third row is to the left of this pivot in the row above it. Okay, so it's to the left. And then this one here does not have a pivot there on position 1 here. Okay, so we're going to say that matrix is not in what? Row echelon form. Okay, so we're going to refuse here. And then when we look at B, okay, we're going to say this here is not in row echelon form. Okay, why is it not in row echelon form? Because we have this 0 row here, okay, which is not at the bottom. Okay, so the 0 row should always be at the bottom, but there it's row number 3. So we're going to say no. Okay, it's not in row echelon form because of this row here. So even here, we're going to say no. And then on C, let's take a close look at C. Okay, we have the 0 row at the bottom. Okay, and then here we have the leading coefficient, and then the leading coefficient in the row below it is to the right of it. Okay, so this matrix here satisfies all the conditions for row echelon form. So we're going to say this one on C there. Okay, we're going to say yes. Okay, so that one we're going to say yes. It's in what? Row echelon form, because all the conditions are what? Are satisfied. All right, what about this matrix on D? Okay, so D, we can see that this one here, it's 0. So there's no pivot, okay, in this first row here. Okay, there's no pivot. Or if we say the pivot is this one, it means the pivot in the row below it, it will be to the left. Okay, because this will be the first non-zero digit there in the second row. So it will be the pivot there. But that pivot is to the left of the pivot in the what? In the first row. So we're going to say this one here is not, okay? It's not in row echelon form. So what about this one on E? Okay, so this one on E, we have the 0 rows at the bottom. Okay, that's nice. And then this one here has the pivot there. Okay, and then this one also has the pivot there. So this 6 here, which is the pivot in the second row, is to the right of the pivot in the what? The first row. So it means it satisfies the condition that we want. Okay, so we are going to say this one here is indeed in what? Row echelon form. Okay, so this one here on E, we're going to say yes. You see, in row echelon form. And then the last one there is not in row echelon form, as long as you see that this 0 row here is not at the bottom. Okay, so we're going to say here no. Okay, so you are going to be examined on this, so you have to understand this concept here. Okay, you will just bring a matrix and then you ask you, is this in row echelon form or is it in reduced row echelon form? So if you don't know those conditions for that matrix to be in row echelon form, you're not going to answer that question. So make sure you understand the conditions there. All right, so is there any questions here before we move to the next concept? Okay, so if there are no questions, I'll move. All right, so sometimes, okay, sometimes you are given a matrix which is not in row echelon form, as well as it's not in reduced row echelon form, and then you are asked to put it in row echelon form. Okay, so what do you do in such case? Okay, you have to use what we call as the elementary row operations. Okay, so these operations, there are 3 of them. So guys, please understand these elementary row operations. Okay, but because if you don't, you won't be able to put any matrix in row echelon form or reduce echelon form. So there are only 3 elementary row operations. Don't create your own. Okay, don't create your own. So just use these 3 that you can see here. So the first one, the row, uh, the elementary row operation that we have is what we call as the row swap. So we can change the rows. Okay, we can swap the first row, we make it the second row. Okay, and then the second row, we make it the first row. In our quest to put it in row echelon form or reduced row echelon form, we can swap the rows. So for example, okay, I'm going to give an example here. So for example, if I have this matrix here, maybe 1, 2, and then 3, 4. Okay, but what we mean by row swap is that this row here becomes the first row, and then this row here becomes the second row. So if we do the row swap, it means what we're going to have is 3, 4, and then 1, 2. Okay, let me write that 2 properly, and then 1, 2 like that. Okay, so you've seen what we've done here. We've swapped the rows. The one that was the first row has become the second, and then the one that was the second has become the what? The first. So we can use that technique there, okay, in our quest to put a matrix in row echelon form or reduced row echelon form. Right, so this is the first row operations. Don't create your own, okay? And then the other one, which is the second one, is what we call the scalar multiplication, okay? So you can multiply a certain row with a scalar, okay, in your quest to put it in row echelon form. So for example, if you have your matrix 2, 1, okay, maybe 3, 4, this is your matrix, okay, you can say this row 1 here, I can multiply it, okay, so I'm going to say my new row 1 will just be equals to 2 multiplied by row 1. So it means whatever is in row 1 here, I'm going to multiply it by 2. Okay, so what I'm going to have is that 2 multiplied by 2 to be 4, 2 multiplied by 1 to be 2. And then this second row remains the same, like 3, 4. So what we've done here is what is called scalar multiplication. So we've multiplied a row by a scalar which is not equal to 0. Okay, we've multiplied a row by a scalar. So by a scalar, we just mean a number, any real number. Okay, any real number that you can get. Then you multiply that row with that real number, you're going to get a scalar multiplication, or some people say a scalar multiplication. Okay, just differs the pronunciation. So this is the second elementary row operation that you can use, okay, in your quest to put some matrix in row echelon form or reduce echelon what form. All right, and then from there, you are going to look at the third one. Okay, so this third one is the most used. So this third one, okay, states that you can add, okay, you can add a scalar multiplication of a certain row to another row. Okay, so here, for example, I have this Rj as my row, and then I multiply it with a scalar k. So this scalar is any real number. Okay, the product that I'm going to get there, I add it to another row. Okay, so that's what we call as row addition. You are adding a scalar multiplication of another row to another row. Okay, so we do this so that we can put the matrix in what row echelon form or reduce row echelon form. Okay, you are also going to use it when you are doing when you're finding the inverse, okay, of the matrices. Okay, you are going to stop to use that formula that you are used to finding the inverse. You won't use that anymore. Okay, you'll be using elementary row operations. Okay, so in short, okay, what I can say is that everything that you are going to do once you learn these elementary row operations, everything that you're going to do in linear algebra, okay, will just be based on elementary row operation. Okay, because anything that you want to solve, you be required to use the elementary row operations. So if you miss them here, it means everything that will be coming in front, you are not going to be able to solve because you didn't understand the elementary row operations. So they are just three, but very important for the entire course until you write your examinations. Okay, so please, guys, understand them. Okay, so that is the third elementary row operation there, where you are adding a scalar multiple of a certain row to another row so that you come up with another row, okay? Or you come up with a new row. Okay, so let me give an example here of what I mean there. Okay, let me give an example of what I mean. So what we mean is this. So for example, if my matrix is, okay, my matrix, let me just say 1, 2, and then 0, 1. Okay, if this is my matrix, and then I say this is my row 1, okay, this is my row 2. And then I want to do something to this row 1, okay, using this row addition here. I want to say my row 1 will be equals to, okay, this same row 1 plus 2 multiplied by what? Row 2. So it means this here would determine my new row 1. So my new row 1 will just be row 1 is equals to, so I get this 1 plus 2 multiplied by 0. I'm just going to get 1, okay? And then this entry here, it's also in row 1. We are going to say that will be 2 plus 2 multiplied by what we have there on the second row there. So in the second row, we have 1 like that. So this is going to be equals to 2 plus 2 multiplied by 1, that will just be 4. So it means after I apply this elementary row operation, my row 1 will be 1 and 4. So my new matrix will have 1 and 4 there. And then this row 2 here is going to remain the same as 0 what? 0, 1. Okay, so that's what we mean by row addition here. Right, so we are going to use these now to change some of the given matrices, okay, into reduced echelon form, okay, or just the row echelon form. All right, so I'll use some questions from your tutorial sheet, okay, and then the others you can try them out. All right, so here now we have this question. Okay, they're saying use elementary row operations to rewrite the following matrices into reduced row echelon form. Okay, into reduced row echelon form. So we have two matrices there. Okay, we have two matrices there. So we are going to write this matrix here in reduced row echelon form. Okay, so let's do that. Okay, so this is the matrix that we have. Okay, so remember we said the leading coefficient should be 1, right? Okay, so this one is already 1, so there's no problem there. So it means we have to make this one here to also be what? 1. And if possible, even this one should be what? 1. Okay, so that one is already 1. And then remember we said the leading coefficient should be the only non-zero digit in that row, right? Okay, so our first operation that we are going to apply here will be the operations that will make this part here to be what? To be 0. Okay, that will make that part to have 0, 0 there. So what we are going to say is that row 1 will remain the same, okay, but row 2 is going to change. So we are going to apply this row operation. We're going to say row 2 becomes row 2, okay? So on row 2, what do we have here? We have 4, okay? So if I want to make this 4 0, what am I going to do to this first row? So that if I do 4, okay, and then I put an operation with this 1 here, it's going to give me 0. Okay, that will just be minus 4 and then row 1. Okay, so it will make sure that here I will have not 0 because row 2 I will have 4 and then minus 4. And then what do I have on row 1? I have 1. So when I subtract this, I'm just going to get 0. So that's what we want. Okay, and then row 3 is going to become this. So I'm going to say row 3 will become, okay, I have row 3 there, which is minus 1. And then on top there, I have 1. So it means I just have to add row 3 and row 1 to make this minus 1 to be what? To be 0. So I'm just going to say plus row 1 here. Okay, so what we're going to form now will be this. So the first row is untouched, so it remains the same thing like that. Okay, and then this second row here, okay, it will have new numbers. Those new numbers will come from this row operation that we are applying. So the first one is 4 minus 4 and then 1. So this is giving us 0. So that's what we want. So here it will be 0. The second one it will be row 2 we have 5 minus 4 and then row 1 we have what? 2 there. So it will be 2. So this will give us 5 minus 8. So this will just be what? Minus 3. So it means here I'll put minus 3. And then here on 6 it will be 6 minus 2. 6 minus 4 I mean. And then 3. Okay, so this will give me 6 minus 12. Okay, and then this will just be what? Minus 6. So I'm going to put minus 6 there. Okay, so we are done with row 2. So this is our new row 2 when we applied this row operation here. Okay, and then let's apply this row operation here to the row 3. So row 3, we said it's just row 3, the entry that we have on row 3 plus the entry that we have in row 1. So this will be minus 1 plus 1. So that will be 0. Then here it will be minus 1 plus 2. That will be 1. And then here it will be minus 1. Okay, to be minus 1 plus 3. That will be what? 2. Okay, so that's what we get when we apply the first set of row operations. Okay, so you ask yourself, is that matrix there in row echelon form or in reduced row echelon form? No, it's not. Okay, because here I still have this, I still have this, and this pivot is not 0, and I still have this, and I still have that. Okay, so we are still simplifying this. So the next step now, okay, we are going to say, let's try to um, let's try to maybe do a swap. Okay, so you can do it in any way that you feel like. Okay, the answer is going to be the same as long as you are finding the reduced row echelon form. So I can say, okay, I feel like, okay, I can say I feel like I can divide this row 2 here. Okay, I can divide everything by minus 3. So I'm going to say row 2 has become minus 1 over 3 and then row 2. Okay, so it means the new matrix that is going to be formed would be row 1, okay, and row 3 will remain untouched. But this operation here is just touching the row 2. So the row 2, we are saying the new row 2 should be, okay, row 2 is going to be minus 1 over 3 and then multiplied by row 2. So the first one is just 0 there. So this will be remain 0. And then the other one to be row 2 is equals to minus 1 over 3. Okay, here we have minus 3, so I'll put minus 3. So this will just be 1, so I'll put 1 there. And then this one is minus 6. So row 2 there will just be minus 1 over 3 and then minus 6. So this will just be what? 2. So what do I have there? Okay, what do I have there? I have, okay, there I'll have 2 like that. Right, so we can see that these two rows, this one here, row 2 and row 3, they're just the same. Okay, row 2 and row 3 are just the same. So it means that what we need to do here, okay, is make, okay, let me just erase this. So what we need to do here, okay, is make this 2 0 and this 1 0. And then we also make this 2 0, this 3 0, and then we make this 2 here to be what? 1, because it's a pivot, so it should be 1 in reduced row echelon form, remember? Okay, so what are we going to do there? Okay, what are we going to do there? We are going to say, okay, from there, let's try to, okay, from there, let's try to, um, okay, let's try to subtract. Okay, let's try to subtract. Um, we want to make this one here to be 0. So let's try to subtract those. Okay, let's try to subtract those. So we are going to say row 1. Okay, let me say this. Row 1, okay, is going to be equals to, okay, row 1 minus 2, row 3. Okay, so this means that I'm using this row here and this row. Okay, remember, I want to make this 2 to be a 0. Okay, so what am I going to get there? I'm going to get this. So in row 1, this one will be 1 minus 2 of this, it will just remain 1. This will be 2 minus 2 of this, it will remain 0. And then this one will be 3 minus 2, row 3 here. Okay, so this was 3, row 3, which is 2. So this would be like 3 minus 4. So that one will be minus 1. Okay, and then the row 2 will remain the way it is, like that. Even this one will remain the way it is, 0, 1, 2, like this. Okay, so from there now we can say, okay, let's subtract row. We want to make this one here 0. So let's subtract row 3 and row 2. So we're going to say the operation that we are applying here is for row 3. So row 3 becomes row 3 minus row 2, like that. Okay, so what are we going to have there? Okay, what are we going to have there? So we are going to have, okay, we are going to have, okay, so we're going to have 1, 0, minus 1. And then here we still have 0, 1, and then 2. Okay, and then down there we're going to have 0. And then if I say 1 minus this, it will be 0. And then 2 minus this, it will also be 0. Okay, so this is the matrix that I get. Okay, this is the matrix that I get. Okay, so that matrix now that I have, is it in reduced row echelon form? Okay, so we have 1, 0, then minus 1. We have 0, 1, 2, and then 0, 0, 0. Okay, so I want your participation, guys. So do you think this matrix that I've found there is in reduced row echelon form? Is it in reduced row echelon form? Come on. Come on, guys. Is it in reduced row echelon form? What's your comment there?
It's not,
Okay, why do you say it's not?
because for it to be in reduced row echelon form, it means that for each leading entry, okay, no, it looks like
Yeah, let's
yes, okay,
try.
it
Let's
is.
try
I
to
don't know.
understand it.
No,
Okay.
it is. No, it
So
is.
the way it is in no
Okay.
echelon form, right?
Yes, it is.
Yeah, so anyone who has a different opinion there, anyone who has a different opinion there, do you think it is in reduced row echelon form or it's not?
It is.
Yeah, so I also think it is. Why? Because the last row there, okay, only has zeros. Okay, and then this first row has a leading pivot, which is 1, and then the other ones, they are zeros. Even this one here, okay, it has a leading pivot there, and all the others are 0. Okay, and then at the bottom there, we have the 0 row. So it doesn't matter what you have there. Okay, so we're going to say this matrix here is in what? Reduced row echelon form. All right, so from there now we can look at another example. Okay, we can look at another example. So the other example was this question here. Okay, the other example was this question here. So how are we going to solve it? Okay, how are we going to solve it? All right, so let's solve that one. So this is the question here. All right, so we want to express this question, this matrix here in reduced row echelon form. Okay, so remember we said the first thing that we must do is make the pivots to be what? 1. Okay, so we want this pivot here, this one here to be 1. And then this pivot, if it will exist there, it should be 1. Even this pivot, if it should exist there, should be 1. Even this one there should be 1. But mind you, some of these pivots can disappear as you are applying those row operations. Okay, they will just be 0, maybe somewhere there. Okay, so our first thing there will be to make these two
I have
here
a
to be
question.
1. Yes, you
I
can
have a
ask.
question.
Yes.
Is it a must since the first uh row of row echelon form alone states that all the non-zeros must be all the 0 rows must
Mhm.
be um the last one. I
Yes,
don't know how to
yes,
put
it
it
must be
better.
at the bottom.
And it must be at the bottom. Does it
Mhm.
mean that every time you have to have zeros at the bottom?
No, it's not every time. But
It's a
if
must.
no, it's not every
Okay.
time. So in some matrices, you won't have a 0 row at the bottom. You just have 0, 0, 0, and then at the end you have a 1.
So my aim should be finding, putting the pivots
Yes,
and making sure there is no other non-zero in that column.
yes,
That's
in
all.
that column. Yes, if you are putting it in reduced row echelon form. So there should be no
Okay.
other number in that column.
Okay. Thank you.
All right. So here we are going to start with expressing first of all this guy. Let's express it in row echelon form. And then once we are done with the row echelon form, we're going to express it in reduced row echelon form. Okay. So, all right. So what we are going to do here is that we want to make all these entries below this first pivot to be what? To be 0. So we're first expressing this in row echelon form. And then we are going to come to the reduced later on. Okay. So how can we make those entries below these two to be 0? Okay, we're going to apply an operation, a row operation to this one here. Okay, so we're going to say row 2 should be equals to. So for this part here to have a 0, what are we going to do? We are just going to subtract this row from that row. So we're going to say row 2 will just be row 2 minus what? Row 1. And then row 3 will be equals to, so there I have minus 4. So what can I do to the minus 4 to make it 0? I'm going to say row 3, okay, which is minus 4, and then I'm going to say plus 2 of the row 1. So 2 of the row 1 there, it will give me a 4, which is a positive 4. And then this is minus 4. So that will give me a 0. Okay. And then we also want to make this one here, the 4 down there, to be a 0. So we're going to say row 4 will be equals to, okay, I have row 4 there. Okay. And then what am I going to do to the 4 to make it a 0? I'm going to say minus 2 row 1. Okay. So these operations are the first operation that I'm going to use. Okay. So let's apply those operations. So the first row remains the way it is. 2 minus 2 4, and then minus 2. Okay, what about this one here? What about this one here? Okay, so this one we're going to say 2 minus 2, so there it will give me 0. 1 minus 2, that will give me 3. And then here it will be 10 minus 4 to just be 6. 7 minus 2, it will be what? 9. Okay, and then here it will be minus 4, okay, plus 2 of the 2. This will give me 0. So this will be 0. And then if I go to this 4, it will be 4, okay, and then I have plus 2, then I have minus 2 there. This will also give me 0. Okay, so this one here will be 0 as well. And then if here I have 8 and 4 there. Okay, so I have minus 8 plus 2. And then on row 1, I have 4 there. So this will also give me 0. So I write 0. And then here I have 4, okay, plus 2. And then in row 1, I have what? Minus 2. So this will also give me what? 0. So it means this whole thing here becomes 0, 0, 0, 0. What about row 4? So row 4, we are using this operation here. Okay, so row 4, we are starting with 4 there. Okay, and then minus 2, 2. This will give me 0. So I'll put 0. And then I go to the minus 1 and this minus 2. So it will be minus 1, minus 2, minus 2. Okay, so this will give me what? This will be minus 1. And then here it will be plus. Okay, and then you multiply them to just be 4. So that will give me what? That will give me 4, positive 4, and then minus 1, it will give me 3. Okay, and then here it will be 14 minus 2, and then there on top there I have 4. Okay, so this will just be 14 minus 6, 14 minus 8, I mean. This will give me 6. So here I'll put 6, and then at the end here I have 6 minus 2, and then row 1 I have minus 2 like that. So this will be 6 plus 4. So it means here I have what? 10 like that. Okay, so that's what we get for our fourth row there. That's what we get for our fourth row. So it means, okay, after applying the first set of operations, I'm getting this matrix there. Okay, but that matrix is not in row echelon form. So what are we going to do to that matrix? Okay, so the first thing I can see, I have a 0 row there. So you want to make this row go to the bottom. So what we are going to do, we are going to do a row swap. This third row will become the fourth row. Then this fourth row will become the what? The third row. So what we are going to have here is 2 minus 2, 4 minus 2, and then 0, 3, 6, 9. Okay, and then it will be 0, 3, 6, 10. And then down there I have 0, 0, 0, 0. So you're supposed to show this swap. So you say with 2 arrows like that. Okay, so you say row 3 has swapped with the row 4 like that. Okay, so you show those 2 more arrows. Even these 2 more arrows here, you show them. You just don't do this. Okay, so this is the matrix that we now have. Okay, so we ask ourselves, is this matrix here in row echelon form? Okay, no, because the leading coefficient here is not to the right of this guy here. It's just right below it like that. Okay, so what are we going to do there? It means we can subtract. Okay, we can subtract row 2 from row 3. Okay, we can say our new row 3, okay, our new row 3 will be equals to row 3 minus row 2. So what are we going to get here? So it means the first row will remain the way it is. Okay, the second row, it will also remain the way it is. But the third row is going to change by this operation that I have here. Okay, so we are saying the new row 3 is just row 3 minus row 2. So 3 minus 3, okay, here I'm going to have 0. And then 6 minus 6, I'm going to have 0. And then 10 minus 9, I'm going to have 1. Okay, and then I have that 0 row at the bottom there. Okay, so we ask ourselves now, is that matrix in row echelon form? Okay, so we are going to say yes, because it satisfies everything. So 1, the 0 row is at the bottom there. Okay, 2, the leading coefficient, okay, in the second row is to the right of the leading coefficient in the first row, and the leading coefficient of the second row, the leading coefficient here, which is this one of the third row, is to the right of the what? The leading coefficient in the second row. Right. And then we have that all the entries below the leading coefficient are what? 0. So we have zeros there, zeros there. Even here, below this leading coefficient, we also have what? Zeros. Okay. So all the conditions have been met there. So we're going to say this matrix here, okay, this one here is in row echelon form. Okay. So we are just considering row echelon form. And then from there now we can move to the reduced row echelon form. Okay, but before we do that, any questions here on how we have moved to this matrix here? Right, so if there are no questions, we continue. Okay, so know that this reduced the row echelon form, okay, is not unique. Okay, the row echelon form is not unique. So it means that the answer that you are going to find, you, and the answer that your friend is going to find will be different, but they are all going to be correct as long as you follow the row operations correctly. Okay, it's not unique. The answers might be different that you get. Okay, but as long as you follow the procedure correctly, it means your answer should also be what? Correct. Okay, so the row echelon form is not unique. But when you come to the reduced row echelon form, okay, the reduced row echelon form is unique. So meaning the answer that you are going to get should be the same with the answer that your friend is going to get. But you are going to use totally different row operations, but the answer should be the same when you're talking about the what? Reduced row echelon form. So let's try to put now this matrix that is in row echelon form. Okay, we put it in reduced row echelon form. Okay, so let's erase this. Okay, so we can move this guy here. Okay, so let's move this guy up there. Okay, so we want to put this matrix, right? Okay, this matrix here, which is in row echelon form, we want to put it in reduced row echelon what form. So what are we going to do there? Okay, remember we said all the pivots should be what? Should be 1. Okay, all the pivots should be 1. So it means we have to make this pivot 1 and that pivot 1. So we're going to say our new row 1 will just be equals to 1 over 2 multiplied by row 1. Our new row 2, okay, our new row 2 will just be equals to 1 over 3 and then row 2. Okay, so why am I doing 1 over 3? Because here to make this one, I simply divide by what? By 3. To make this one, I simply divide by what? 2. So if I divide all these by 2, 2, 2, 2, what am I going to get? I'm going to get 1 minus 1, 1 minus 1. Then if I divide this, I'm going to get 0, 1, 2, and then 3. And then this one remains the way it is. Okay, and then even the last one there remains the way it is like that. Okay, so this is what we have as the result when you do our first operations there. Okay, and then from there, from the definition of the reduced row echelon form, okay, since we have made all the leading coefficients to be 0, okay, the next thing is that all the entries in the column where you have your leading coefficient should be what? Should be 0. So we have to make this minus 1, okay, I should use a different color. So we have to make this minus 1 here. It's not changing. Okay, I have to make this minus 1 here to be 0. And then I also have to make this minus 1 and this 3 here to be 0. Remember, the only non-zero entry, okay, in the column where you have a leading coefficient should only be the 1 itself, okay? So let's first of all make this minus 1 to be what? To be 0. So what are we going to do there? We're going to say our row 1 is going to be row 1 plus row 2. Because here I can see 1 and here minus 1. So when I add them, okay, here it's going to be what? 0. Okay, so I'm only making changes to the first row here. So the first row will be row 1 plus row 2. So 1 plus 0 is still going to give me 1. Minus 1 plus 1, it will give me 0. And then here I have 1 plus, um, there I have what? I have 1 plus, okay. Okay, so here it was supposed to be 2, guys. We didn't see it. Okay, here when we divide this 4 here, okay, we get 2 there. So there we have got 2 here. Okay, so 2 plus 2 is going to give me 4. And then here it will be minus 1 plus minus 1 plus 3. Okay, so that will just be 2. So we have applied this row operation to the first row, and then the rest are just going to be the same. So we have 0, 1, 2, 3. Okay, 0, 0, 0, 1, and then 0, 0, 0, 0. Okay, so this is the matrix that we have, and it's not in reduced row echelon form. Okay, so what is the next step from that? Okay, what is the next step from that? So the next step from that, okay, is to make the next step from that is to make this 2 here to be 0. Okay, we have to make that 2 to be 0. So what are we going to do? Okay, in order to make this 2 here to be 0. Okay, and then after we make the 2 to be 0, we will need to make this 3 here to be what? To be also 0. So what we are going to do, we are going to apply row operation. Okay, so these row operations will come up with them by yourself. So you just see the scenario there. So I can say that for me to eliminate these 2 here, okay, I can say that my row 1 will be equals to row 1 minus 2 row 3. Okay, I can see that on row 3 there I have K1, so I can take advantage because I know that the others is 0, so nothing will change here because all these are zeros here. Okay, and then my row 2, my new row 2 will be equals to, okay, I have row 2, which is 3, and then I'm going to say minus 3 row 3, like that. Okay, because here there is 1. So if we apply that, it means these 2 and these 3, they're going to disappear. Okay, so let's erase this so that we have space there on top. Okay, so what are we going to have now? Okay, I shouldn't have erased. Okay, it's fine. So what are we going to have? So this one here, okay, this row 1 is changing. Okay, so remember it's row 1 minus 2 row 3. Okay, so this will be 1 minus 2 row 3. It will just remain what? 1. Then 0 minus 2 row 3. It will remain 0. And then 4 minus 2 row 3. It will remain 0. I mean, it will remain 4 there. And then here it will be 2 minus 2 multiplied by this 1. It will now become 0. Okay. And then even this row 2 is changing. We are using row 3. Okay. So it will be 0 minus 3 row 3, it will just be 0. 1 minus 3 of this, it will be 1. Okay, and then 2 minus 3 of 0, it will be 2. And then 3 minus 3 of this, it will be what? 0. And then the other ones remain the same. So we have 0, 0, 0, and then 1. Okay, so someone is writing on my cupboard here. So let me erase this part. Okay, so that's what we are going to have. And then at the end there, we have 0, 0, 0, 0. So this here is the matrix that we now have. Okay, so you ask yourself now, is that matrix obeying all the conditions for what? For reduced row echelon form. So reduced row echelon form like that. Okay, so what are we going to say here? Okay, so we see that all the pivots are 1. Okay, all the pivots are 1. And in that column where we have the pivot, we can see that only the pivot is non-zero. Okay, the rest are zeros. And then also the 0 row is at the bottom there. Okay, so it means this one, yes, it is in what? Reduced row echelon form. All right, so any questions there? Any questions there? All right, so if there are no questions, I think I'll end here. Okay, I'll end here. I just wanted us to discuss this same concept of row echelon form and reduced row echelon form. Okay, so from your tutorial sheet, you have other questions. So try them out. Okay, so this one here, I've put it as an assignment. So we solved this one. Okay, so you can try out this one and also this one. Okay, you can try them out. So on our website, we have full solutions to all these questions here. So you can access them. Just go on our website, you register an account for yourself, okay? And then you'll be able to access all the solutions to all the questions in your tutorial sheet. Right, so any other questions before we close the class? All right, so if there are no questions, thank you so much for attending. Until we meet next time.